Alright, today's the 24th of April. We're doing problem of the day. I missed yesterday's completely. I'll probably do, okay, this is an easy problem. I might do both. Alright. 2833. Furthest point from the origin. You are given string moves of length n, okay, consisting of L, R, or underscore. The string represents your movement on a number line. Left, right, I assume, or stay. In the ith move, you can choose one of the following directions. Move to the left if... Oh, no, it's a wild card. Okay. Move to the left if moves at I is L, or if moves at I is a blank. Move to the right if moves at I is R, or if moves at I is blank. Return the distance. Return the distance from the origin of the furthest point you can get after n moves. Interesting. I'm assuming this is easy because it's like small numbers. Okay. Is this greedy? Is this... Okay. Let's start by writing the title. 2833 POTD. Okay, so yeah, okay. On a number line, you can move left. If it's an L, you have to move left. If it's an R, you have to move right. So I would assume this is. Let me just jot something down because I just had a thought. If you count how many L's are there, right? So like we'll call that num L's, and similarly find num R's, which is the number of R's that have to be there, then surely it's just a matter of make all dashes L if num L's is greater than num R's, or make all dashes R if num R's is greater than, or one of them has to be equal to, greater than num L's. So for example, L dash R, L dash dash R, L dash R, L dash dash, was it R at the end? Yeah, R. So off the bat, the number of L's is equal to 2, and the number of R's is also equal to 2, so it won't matter. But if so, what that means is both of them, I'm definitely going to go to the left by 2, and I'm definitely going to go to the right by 2. So I'm going to end up back at the origin. So long as all the dashes are the same thing, the same movement, then I will be as far away from the origin as I can. So make the dashes equal L by my rule. So then it will be L, 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 and then by the movement, it will be like, that means total number of L's is equal to 2 plus 3, or in general is equal to 2 plus the number of dashes, which is equal to 5. Number of R's still equal to 2, therefore the displacement is equal to 5 minus 2 equals 3. Yeah. In this case, we have 2 L's, 1 R, so we would prefer to make all the dashes L's. So we have 1, 2, 3, 4, 5, 6 L's after we replace the dashes. 3, 4, 5, 6, and then 1 R, so that's 5. Yeah, okay, I back it. You could probably really formally prove this if you wanted, but I will not, probably. So num L's equals, and we'll do this as Pythonically as we can, dot count L, it's capital, right? Yeah. Num R's equals num dashes moves dot count underscore if num L's is greater than or equal to num R's, return num dash plus, and then num L's minus num r's. I don't know why I put brackets, so there's no need. Else, return this, but the other way around. Whoa. Oh my god. Yeah. So that's just what I said. Like, if this one's bigger, then make the dashes equal to the number of L's. So we're adding those two together and then subtracting that guy off. Otherwise, add those two together and subtract that guy off. I'm quite confident that this is correct. More confident than usual. It is slow. I assume that's because it's 3 loops to do this. Like if I make this 0, I guess I won't do it Pythonically. And then I do for C in moves, if C is equal to L, then num L's increments, else L if C is equal to R, then num R's plus equals 1, else, or maybe I'll just make explicit L if C is equal to the underscore, num dash increments by 1. That be better? Yeah, okay, fine. Fair enough. Okay. But yeah, logic is there. What would be the, besides common sense, what would be the what would be the proof? Because it's like, surely I could prove this. It'd be something like, I guess if we can accept that displacement is equal to the absolute value of number of L's, total number of L's minus the total number of R's, then we can transform the problem into basically trying to maximize this difference. So then it would be something like, what would I say? Suppose, without loss of generality, right? Suppose number of L's is initially greater than number of R's, right? Just like without thinking about the dashes too much, we count the number of L's. It happens to be greater than. Suppose we have n dashes and we make all n dashes become L's, then the distance or the displacement will become n plus num L's minus num R's, versus if we only made n minus k, where k is greater than 0, dashes become L, then distance would become n minus k plus num L's minus k plus num R's, because that's the number of dashes we chose to make R, and this would be equal to num L's minus num K's plus n minus k minus k. So num L's minus num R's plus n minus 2k, which is clearly smaller than n plus num L's minus num R's, because we said k was greater than 0. And so this guy over here is definitely smaller than this guy over here, which was the distance we got when we made all of the dashes equal to L, where we said L is bigger than, number of L's is bigger than number of R's. And then of course you could flip the logic if number of R's is bigger than number of L's. Okay, and if it's equal, then it won't make a difference. Cool. Maybe I can even do this. Yeah, that's like hand wavy, but it works. I can see the proof. That's fine. Okay.